Python and database access. As your Python program grows, you may have need for persistent data storage. The way that most application frameworks work in this regard is to make use of an application programming interface, or API, to connect to one or more database systems. Therefore, in this nugget, I'm going to show you, first of all, the basics of connecting Python code to a relational database management system, or RDBMS. Specifically, we're going to focus in on the SQLite compact RDBMS that ships as part of the standard Python library. The good news is that what you learn here in this nugget regarding SQLite is directly transferable to whatever your chosen permanent database platform is, whether that's Microsoft SQL Server, Oracle, MySQL, etc. Let's get to work. Now, when we talk about connecting disparate systems, for instance, a Python script to a relational database management system, this involves talk of some kind of connector or translator or interface between those two systems. An API addresses this need. An API stands for Application Programming Interface, and we can draw an analogy to computer and programming APIs to human-computer interaction. Think of what happens when you sit down at your computer. You have interfaces for inputting data or sending data into the computer to be processed. You have your keyboard, you have your mouse, you may have a headset with a microphone. All of those represent interfaces to connect one entity, namely you, the human being, to a second entity, in this example, a computer system. So the trick when you're learning a programming language is to get hold of those rules, those specifications, those data structures, functions, routines, etc., that are published by your destination entity. So for instance, if we wanted to connect Python to Oracle, our job is to see if Oracle itself or some third party has published an API specification that enables us to pipe our Python into an Oracle database. Now, some standard database APIs that are out there in the world include the following. Perhaps the most popular is ODBC. This stands for Open Database Connectivity. In the Java world, we have the Java Database Connectivity Standard, that's JDBC. In the Microsoft .NET Framework world, there's the ActiveX Data Object, or ADO. Now, what's crucial for us as Python developers is that we need to understand that the API published by Python to support connectivity with relational database systems is called DB API version 2.0. Now, the good news is that there are lots and lots and lots of API providers. Therefore, you can quite easily hook in Python to any contemporary RDBMS. There's the MySQL for Python library, there's CX Oracle for Oracle, there's ADODB API for connectivity with Microsoft SQL Server, there's Pygre SQL for PostgreSQL, and the list just goes on and on. The thing to remember again is that as long as we're using a library that uses DB API, it's not only easy to get Python talking to a particular RDBMS, but it's also easy to go from one RDBMS to another. You might have a Python project that's currently interacting with MySQL, and then due to an architectural change, you now need to get that code talking to Oracle. The amount of code you'll have to redo using DB API is very small thanks to these API standards. In the Python wiki at wiki.python.org, there's an excellent article on database programming that I think you should read. It talks about relational databases, the DB API particularly. You can read FAQ lists on it. PEP 249 is the official specification document for the DB API. This page here, Database Interfaces, is particularly useful, I think. This goes in and allows us to take a look at specific database systems, DB2, Mozilla Firebird, IBM Informix, and so on. And what happens, you can click these, and the Python folks have been nice enough to give us pros and cons of connectivity between Python and that database system, and also they'll give you a list, a current list, of DB API 2.0 drivers or modules for each platform, and you definitely have some choice here. I'm just looking at MySQL, and I could download MySQL for Python, or I could download MXODBC, or I could download PyODBC. You see what I'm saying? So you'll absolutely want to do additional research to read the pros and cons of choosing a specific DB API library to connect to your chosen database. As I stated at the beginning of this nugget, we're going to look in this nugget at SQLite interaction with Python. SQLite is a tremendously powerful little library. It's actually less than half a megabyte in size. It's written in C, and what SQLite has going for it is that it's not a client-server system. That is to say, for instance, if we wanted to get a Python application writing to a database we create in MySQL, well, there it stands to reason that we have the MySQL daemon or server process running on our own or a remote box. That can become really cumbersome, especially when we're porting an application from one development environment to another. SQLite, on the other hand, is an ACID relational RDBMS. ACID is pretty much, to use the term recursively, the acid test for whether a relational database management system is truly standards compliant and in particular transaction safe. A stands for atomic, C stands for consistent, I stands for isolated, and D stands for durable. These are core elements of what a database transaction is. Now, of course, you'll notice that we don't have the time or space in this training to give full treatment of what an RDBMS is and to really deep dive into the structured query language in particular. I do want you to be aware that I've created not one, not two, but 3 CBT Nugget series on MySQL, and you'd be well advised to take a look at those. Actually, I've done another CBT Nugget series on Microsoft SQL Server 2008. Any of those training products would give you a really nice understanding of what ACID means. It'd get you familiar with the structured query language and the basics of RDBMS design, administration, and development. Anyway, SQLite is a linked ACID-compliant transactional database management system. Linked means it's actually embedded as a library in your application. Now, what are the benefits there? Certainly portability, wherever your application is, your SQLite database is. Another one is speed, tremendous speed, because we don't have any latency introduced with inter-process communications or IPS traffic. In other words, you have your Python program running in one process on the system, and then let's say MySQLD running as another process. There's obviously going to be some latency there with those inter-process communications. Here, your Python application and your SQLite run in the same process, so it's